We're going to talk about the product rule for finding a derivative. This is when you have two functions multiplied together. This would be the rule for that. I know some of you have asked me, can't I just find the derivative of each one and multiply? Well, you can't, so I'm going to show you a couple different reasons why and a couple examples to show you the difference between it. But if you have h of x equals f of x times g of x, which is two functions multiplied together, then the derivative is f of x times g prime of x plus g of x times f prime of x. Usually I say it in words, and I call this the first function and this the second function, and I say first times the derivative of the second plus the second times the derivative of the first. That's just the process I use, and I think it's easier to memorize the process when you say it in words. So we're going to look at this problem. There's actually two ways that you can solve it. I'm going to do it as if we didn't know the product rule first, and then I'm going to do the product rule to show you how it's different. So this, you could have done this without knowing the product rule by just simplifying first, like multiplying it out. You get 15x plus 12x squared minus 10x squared minus 8x to the third. And if I simplify that, that's 15x plus 2x squared minus 8x to the third. And now if I want to find its derivative, I can just use the power rule like we did. And you get 15 plus 4x minus 24x squared. I personally think that's easier than doing the product rule in this problem, but I wanted to show you that you still could use the product rule. It just takes a little bit more work. So if I were going to use the product rule here, I would start with the first function, which is this one here. I would multiply it by the derivative of the second, which would be just 4. And then plus the second. And then I would multiply by the derivative of the first, which comes out to be 3 minus 4x. And that's the derivative. So I didn't have to simplify it first. But now I have to simplify 4 times both of those terms. And then I have to FOIL here, so I get 15 minus 20x plus 12x minus 16x squared. And now when I combine, if I combine those, that's negative 24x squared. Combine the x's. That would be 4x. And then the 15 is separate. Notice that both of those are the same. You just have to decide whether you want to simplify first or simplify at the end. The others that we'll do, you have to use the product rule. This was just one to show you both ways. Alright, this one, we would do the product rule. And there's your two functions if you want to kind of put parentheses around them. The first function will be 3x squared. So first, derivative of the second, so that would be cosine, plus the second, which is sine, times the derivative of the first, which comes out to be 6x. Whenever we're doing the quotient, you do have to factor out some common terms because things may cancel, but when you're doing the product, unless things can be simplified, it's okay to leave it like that. Alright, so this one, you're going to do the product rule for the first part of the equation. But then we're just going to find the derivative of that just outright because it's not a product, it's just a number times a function. So I'm going to do the product rule first with 2x and cosine x. So the first times the derivative of the second. Derivative of cosine is negative sine of x. I'll put that in front of the 2x. Plus the second, which is cosine, times the derivative of the first, which is 2. And then I just find the derivative of that, which the derivative of sine is cosine, so that's 2 cosine of x. Notice those go away, and you get negative 2x sine x. There's plenty of times that things will simplify, and you should check that as you work them out. Alright, the quotient rule is a little bit longer, but a similar process. So let's say that you have h of x is f of x over h of x, and f of x over g of x, and you want to find the derivative. Here's how you do the derivative. It's g of x times the derivative of f of x minus f of x times the derivative of g of x over the bottom squared. Alright, now sometimes I have a saying for this one. Instead of first and second, I call it top and bottom. I'm not going to write this down just because there's not room here at the bottom, but you can write it if you want. I start with the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Alright, so like we did with product rule, when I show you there are two ways to do this problem. I do think both ways will work, but you just have to decide which one you like better. They both do simplify to the right answer. So on the first way is the way that we did previously. You can divide each term by x and to simplify, and you would get 2x minus 3 plus 1 over x. And then, because all I did was I just divided 2x squared by x, 3x over x, and then 1 over x. And then when I find the derivative, I would get 2. The derivative of 1 over x, keep that in mind, that's x to the negative 1. So the derivative would be negative x to the negative 2. Obviously the answer is simpler that way. However, some of you will like the other way better. You'll just have to practice and see. So for the other way, we're just going to start off with the product rule. You'll start with the bottom. The derivative of the top is 4x minus 3. And then you do minus the top times the derivative of the bottom, which is 1, over the bottom squared. Alright, you do need to simplify the top. You're going to multiply x by those two terms. That negative is going to go to all those terms there. Simplify just a little bit more. 4x squared minus 2x squared is 2x squared. 3x and 3x will go away, minus 1. And whether or not you notice this, if I kept on with this side and got a common denominator, those two things would match. I am okay with either form. You do not have to get a common denominator and get the first one to the second way, but both of them are the same answer. They're just written differently. Alright, so let's look at this one. Remember, you can't just find the derivative of the top and then the derivative of the bottom and then divide. Same as product. So that's why you have to use this rule. So we're going to start with the bottom, which is x squared plus 1. The derivative of the top is 5 minus the top times the derivative of the bottom. Derivative of bottom is 2x over the bottom squared. Most of the time you do not need to square out the bottom. Most of the time that you can leave it like that, or sometimes even things will cancel. So you do not want to square the bottom, but you do need to simplify the top. So I'm going to multiply 5. And then I'm going to multiply this out, and notice that there's a minus there, so I do need to change those signs. So it will be negative 10x squared. Alright, if I multiply, that's negative 4x, but change the sign so it will be positive 4x. Leave that alone. 5x squared minus 10x squared is negative 5x squared. And plus 5 plus 4x all over the bottom, which is x squared plus 1 squared. And we can leave it like that. There will be times that things will factor or cancel, but not on this particular problem. Alright, this problem you can do by using the quotient rule. And I'm going to go ahead and do it that way, but then I'm going to show you there is a simpler way on this one, and you may already know it by looking at it, but I'm going to do it just so you can see it. So if I do the quotient rule here, it would be bottom times the derivative of the top minus the top times the derivative of the bottom, which is 0, over the bottom squared. Alright, since this is 0, that just kind of goes away. You get 6 times 2x plus 3. I'm not going to multiply by that 6 because I realize that there's a 36 on bottom and I can reduce. So I get 2x plus 3 over 6. Now, you can simplify this by dividing each term by 6 and make it 1/6 x squared plus 3 over 6 is a half, so a half x. And then if I find the derivative that way, I would end up with 2 times a 6, which is a third x, and then a plus a half. And this answer and that answer are also the same. So it is simpler the first way, but I know some of you won't catch it, so I wanted again to show you both ways on that problem. Alright, number 7. This is an interesting one. It's f of x equals tangent of x. After I do this one, you may want to remember this rule, but I do want to show you where it comes from. So first thing you should know is that tangent of x is the same as sine of x over cosine of x. So if I'm going to do the derivative, I'm going to start with the bottom, multiply by the top, the derivative of the top, sorry, minus the top times the derivative of the bottom, and then over the bottom squared. So cosine x times cosine x is cosine squared of x, and negative sine times negative sine is positive sine squared of x. Now, interestingly enough, there is an identity that you probably need to know. Sine squared x plus cosine squared of x equals 1. It's called the Pythagorean identity for trig. So you end up with that. That's the rule. Tangent of x, the derivative, is 1 over cosine squared of x. Your book and some books use secant squared of x instead of 1 over cosine squared of x. Both of those mean the same thing. So whichever way you would like to write it is perfectly fine. But I wanted you to see where that came from and use the quotient rule in the same thing. So 1 over cosine of x does equal secant, so you can write it either way. Alright, another trig one. This isn't a special rule or anything. I just want to use the quotient rule with it. So we would start with the bottom. The derivative of the top. Okay, the derivative of 1 is just 0. Derivative of cosine is negative sine, but we have the negative with it, so it would be positive sine. Minus the top times the derivative of the bottom, which is cosine of x. Whenever you do sine of x squared, you can put the squared in front of the x or after the x as long as there's a parentheses. Let's simplify this. You get sine squared of x. I'm going to multiply through here, so I get negative cosine of x and then positive cosine of x squared. And I told you it wasn't a real rule. Well, it's not really, but there is something that you can simplify just like I did on the last one. Sine squared of x plus cosine squared of x does equal 1, and so you end up with 1 minus cosine of x over sine squared of x. Alright, there's a couple other variations with the product rule and the quotient rule. This particular one, it looks complicated because of the 1 over x, but if you will multiply every single term by x, you're not really changing the problem because you're multiplying by x over x. So it will make it simpler. Make that 3x minus 1 over x squared plus 5, because I multiplied the bottom by x and I multiplied the top by x. So I really just multiply by 1. And so now if I do the quotient rule, I get the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. you do need to simplify. That would be 3x squared plus 15. Multiply that out, negative 6x squared plus 2x over the bottom squared. If I simplify that, I get negative 3x squared plus 2x plus 15 over x squared plus 5 squared. Alright, I realize I messed up. I'm sorry. At the very beginning here, when I multiply by the x on the bottom, that should have been x squared plus 5x. I'm sorry. So there's an extra x, and I'll show you where that comes into play. So there's an x here, bottom times derivative of the top, minus top times derivative of the bottom. So there should be 2x plus 5 right there. Sorry for the confusion. Alright, so then I multiply 3x squared plus 15x minus, and now we FOIL, 6x squared, that'll be minus 15x minus 2x, and then minus 5. So when I combine these, I still get a negative 3x squared. And then I have okay, that's really a plus 2x, so that's still correct, because here it was a minus 2x, and then the other minus made it a plus. And then the 15x's go away, so instead of a 15 on the end, that's really the only change. It's a minus 5. Sorry for the confusion. Alright, here's another variation of using the product rule or quotient rule. You can start off by using the product rule if you want, but in the middle of it you would have to use the quotient rule. I personally think it's easier to go ahead and just multiply. And then the only rule I have to use other than power rule will be quotient rule on the second part of it. When you multiply, this is like x over 1, so you don't multiply 1 times x plus 1 on those fractions. So for the derivative, the 5 just stays like it is, and now I'm going to do the quotient rule for that second part of it. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Then I want to simplify 2x times both of those, so 2x squared plus 2x, then minus x squared, that's all on the top. X plus 1 squared is still on the bottom. Still have that 5 there. Alright, 2x squared minus x squared is x squared, and then we have our extra 2x, and then x plus 1 squared. Alright, we need to do one that has a trig function that's not sine, cosine, or tangent. And I just want to remind you real quick, I'll come back to it, but cosecant is 1 over sine of x, secant is 1 over cosine of x, and cotangent is 1 over tangent of x. There are rules for the derivatives of each of those, but I think that if you can just know how to change them and use the derivatives that way, it will be easier. So on this problem, instead of knowing a rule, I'm going to rewrite cosecant as 1 over cosine of x, and then I'm going to find the derivative. So the first part is the same as 6x to the negative 2, and then I'll have to use the quotient rule on the next part. I'm probably just going to change that to a plus and change that to a negative. It'll just be easier when you do the quotient rule. So the derivative will be, for the 6x to the negative 2, it will be negative 12x to the negative 3. And now I'm going to do the quotient rule. Bottom times derivative of the top minus the top. Top's already negative, so it would be plus 1 times the derivative of the bottom over the bottom squared. And if I simplify, Then on the top I just get a negative sine of x, and on the bottom I'll get cosine of x squared. Alright, last thing in the video, I need to tell you about the second derivative. The second derivative means you find the derivative and then you find the derivative again. Basically, it's exactly what it means. And here's some notations. F double prime, or you kind of write it this weird way with, you can put 2's outside the d's and outside the x's. I don't know why it's not consistent, but that's the notation that I've seen lots of times to find the second derivative. So let's do a couple problems that way and then we'll be done. So you start by finding the first derivative. The derivative of x to the third is 3x squared. The derivative of 4x squared is 8x, and then this is x to the negative 2, and I've got a negative here, so that would be negative a half times negative 1, which is a half. Subtract 1 on the exponent, so negative 3 halves. And then the second derivative, I just do the derivative again, so I get 6x minus 8. Alright, I'm going to multiply a half times negative 3 halves, so I get negative 3 fourths. Subtract 1 on the exponent, so negative 5 halves. Alright, one more. The first derivative of 4 sine of x would be 4 cosine of x. Now if I find the second derivative, the derivative of cosine is negative sine, so it would be negative 4 sine of x. Just keeps going back and forth between sine and cosine. Alright, here's your try problems. I just want to know what the first derivative is. First one using the product rule and second using the quotient rule.